Hello everyone and welcome to this new lecture, and today we are going to discuss about the displacement reaction. So let's have the quick recap that we have done in the last class, and that what we have done with the endothermic reaction, in which we need to provide some energy to the reaction to take place, and we were providing energy by any means, whether it was a light, whether it was some heat. Okay, so we can just forcing that reaction to take place by providing some additional energy to it. Okay, so that was in the last lecture. So let's continue with the today's topic, and that we have the displacement reaction. So let's start with this. So at so let's start with this, and first of all we having the activity, and what the activity is telling all about, that we have to take first what okay we have to take the 3 iron nail. Okay, we have to take 3 iron nail and take the 2 test tube marked A and B. So let me take 2 test tube here. Okay, we are taking 2 test tube, and it's test tube A and it's test tube B, and we have to fill the copper sulfate solution in here, and we will find that copper sulfate solution is blue in color. So let me fill it with the blue color, and we are also keeping this solution. Okay, so let me fill it also. Okay, so I'm filling it with the copper sulfate solution. Now we have to clean the iron nail, basically to remove all the rust. Okay, now put 2 iron nails in this solution. Okay, this is iron nail basically. Let me make it clear. Okay, so tie the 2 iron nails and put them, dip them in a copper sulfate solution. Okay, so if I could take some another color. Okay, yeah, now it will be more good to see. Okay, so let me remove this, and now this 2 iron nails has been dipped into it. Okay, so what we have, when we will leave this solution for 20 minutes, we will see that there is a black layer formed on the iron nails, and you can see compare with the 3rd iron nail, okay, that you have left, and you can see the color of copper sulfate solution. Here the copper sulfate solution, this blue color, does disappear. Okay, and fades away basically, and you can see there's a change if we have kept these things and this iron nail and this test tube for the comparing the changes. Okay, so you can compare the change by these methods. Okay, so you can see these things in your lab if you perform some experiment at your school, but nowadays we are not performing any experiment. Okay, so here I have just tried to visualize the things. So what we have observed, so that what we have observed, iron nail become brownish black, you can say that somehow blackish. Okay, now the color of the copper sulfate solution fades away. The color as that fades away, that I have already told you. Okay, now what is the reaction? The reaction is here, that the displacement reaction is taking place. Okay, so displacement reaction is taking place. So what we can do here, so iron and copper sulfate, that's basically the reaction is taking place between iron and copper sulfate, because we have used copper sulfate solution. Okay, so what is taking place actually is that iron has displaced this copper and formed the iron sulfate bond and released the copper here. Okay, so what we can see, so what the result that we found here, that iron is more reactive than copper. Okay, if iron would not be more reactive than copper, then it could not displace the copper. So it is very, very important to know that we find a result that iron is more reactive than copper. That's why it displaces the copper and form iron sulfate over here. So this is basically the displacement reaction taking place. So now we are able to define the displacement reaction. And what is the displacement reaction? The reaction in which an elementary substance displaces a set-free constituent of an element from a compound. Okay, so you can see here it was a compound, it was set free compound, and now it has been displaced. Okay, and copper has been displaced from this compound form, and the new compound has been formed, that is iron sulfate, and copper is being released. You can see the precipitate at the below. Okay, or we have seen the copper sulfate solution layer on the iron nail for this experiment. Okay, so this was your displacement reaction. So let's continue further what we have. So what is the reaction tells that I have discussed already. So that is that Fe, iron, is more reactive than Cu. Okay. So some more example that we can see over here for the displacement reaction. If we take zinc granules, okay, in some copper sulfate solution, you will see that the copper, again some color will fades away, and you will see the zinc sulfate solution will form, and copper will somehow, you can see the precipitate in the beaker. Whereas the lead with a copper chloride, okay, so lead chloride will form, okay, Pb, and copper will released again. So you can see here again the displacement reaction. So from this result we have just come to conclusion that zinc is more reactive than copper, lead is more reactive than copper. So at the end of this lecture, that I'll give you the reactivity series, because it is not convenient to perform every time these kind of reactions. So if we have to write in the exam, then we need to learn those reactivity series, and that would be very important for us. Okay, although we have to do the reactivity series in chapter 3, that is metal and non-metals, so we will do there as well. Okay, so what the next we have, that is displacement reaction, and this we will do it right now. Okay, let's start. Okay, so what is displacement? Double displacement reaction, sorry. Okay, it is the double displacement reaction. So here you can find, earlier we were watching it, that there was only one compound, okay, and which was being displaced. But as for its name, it's very much clear that there is two substances being displaced. So you can see the similar kind of reaction, that there will be two compounds and they will displace each other. Okay, so take about the 3 ml of the sodium sulfate solution, okay, and that is white solid basically, and 3 ml of barium chloride, which is white, and it's toxic, so never try to taste it. Okay, which and yellow green on a flame, when you burn it, it's yellow green. Okay, so that's the additive information if you want to know. Okay, so mix this solution, and what we will observe. So we will observe that you can see here, okay, that sodium sulfate, when mixed with the barium chloride, it's formed the barium sulfate and sodium chloride. So here we have seen that the sodium sulfate has formed a sodium chloride, and barium chloride forms barium sulfate. Okay, so both of them displaces each other. So here the double displacement reaction took place. So that's why it is known as double displacement reaction. So you can correlate with the name, that why it is named as double displacement reaction. Okay, so now let's define it. The reaction in which the exchange of ion between the reactants takes place is called double displacement reaction. Okay, so we're having another example, that we have that potassium iodide, which is white in color, and lead nitrate, that is colorless basically. Okay, so again here you can see the reaction taking place, that potassium nitrate has formed and lead iodide has formed. So both of them displaces each other. Okay, and that's why it is called double displacement reaction. Okay, so precipitation reaction, that's the last topic that we will do for today. Okay, so the creation of solid from the solution. Earlier I have told you that here the copper will form a precipitate. Okay, so here a copper will form a precipitate. That is basically a precipitate. The reaction in which this kind of precipitation is taking place, that's in a simple word we can say them also as a precipitation reaction. Okay, so creation of solid and the formation of insoluble salts when the two solution containing soluble salts are combined. So here we have seen that in the displacement reaction, double displacement reaction, there were the two salts. Okay, so one would maybe settle down at the bottom, and that's why we can call them as the precipitation reaction. So that's all for this lecture, and we will continue some new topics, and that will be the oxidation and reduction. Okay, in the next class. So hope you are enjoying the video. Be safe. That's all. Bye bye. Take care. And please do subscribe the channel. And that's very important because most of my viewers are not subscribed my channel. So please do subscribe the channel and do your valuable feedbacks so that we can improve ourselves as much we can. That's all. Bye bye. Take care. Thank you.